All right, I think we've done a problem like this before for Algebra 2, Math Excel Homework 2.6.36 question. And the way we've done it, we've had an equation for a ball that's t seconds and your initial velocity term and then your gravity effect there. So the distance that the ball, the height of the ball, is given by that equation. Thrown from a height of 5, straight up, initial height. And then the equation, when will the height of the ball be at 40? So that's just saying, when will this equal 40? So if I were doing that, I'd throw that 40 over to the other side. And then if I subtracted 40 from 5, I'd have a negative 35 for that. And then I don't know that anything's going to simplify. So you could quadratic formula it. If you know how to use your Desmos or graphing calculator, you can put it in there. But one of your methods you could use there to find my 2 times. Now, the negative time, if we get a negative answer here, it's not going to be anything that we can use because we're starting at 5, it's going up and coming down. So if we have a negative answer, that's before we've been through the ball. So we just need the positive solution here. And I'm actually using a graphing calculator to do it, putting in negative 16 x squared plus my 70 on my x, and then I don't know, we can either put the plus 5 and put a second equation and look for where they intersect, or we can do the minus. I'd probably do the minus 35 because then you can still do your quadratic formula if you'd like. You know, you could work this out with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and you could solve that to get your solution as well. And after you have that, well, I mean, look, I'm seeing 2 different answers here, because if it's, when does it reach a height at 40 feet, there is 2 times for that, because your 40 is above your 5, so there's 1 here and 1 here. So you would find those 2 solutions by evaluating that quadratic formula. And if where I'm doing it, if it says you can use decimals, you can put it in a calculator, evaluate that out, and come up with something like negative 70 plus the square root of 70 squared minus 4 times in parentheses negative 16 times in another parentheses negative 35. Hit enter to get all that. That was a negative number divided by my negative 32. So I've got like negative 5. I've got positive 0.57577. So this first time right here, that's what that would be. And redo the exact same thing except with a minus in that quadratic formula instead. Dividing by your negative 32. This time I'm coming up with like a 3.8 for this time over here. So there's my 2 times that the ball reached 40 feet. When will the height of the ball be 50 feet? Well, I'm gonna quickly put my original problem, negative 16x squared plus 70x plus 5 in my graphing calculator or Desmos. And then after I have that in there, put the second equation in of 50, y equals like a 50 for a horizontal line up at 50. And then look for where the two intersect. And when I see the two of these intersecting, that 50 would seem to be just right in the middle again. Negative 16x squared plus 70x plus 5. So then second trace, which is calculate for the intersection of those points. And I could see one of them. So this was a little higher, so it'll be a little further over and a little closer in on both of these. So like in these two spots. So I've got a 0.78 right there. And then second trace calculate the intersection 5. Select the two graphs. Move closer to the second point, and I've got like a 3.6. And then the last one, if I'm doing a graphing utility to find it, I'm going to put my second equation up at 130. And so when I check that on a Desmos, a graphing calculator, or whatever, at the 130, I find on my graph there, so I'm setting two equations. I'm setting one of them equal to the negative 16 using an x just because that's what the program understands. That was this height. And then setting a second equation for when it equals on part B the 50, and then I'm doing the same thing on the next one, but I'm going to see where it equals 130. And the 130 line is up above the whole thing, so that for that one, there's no solution. It never does reach that height. But that's the way I would set that up. You could do it with algebra. You could do it with Desmos. You could use a graphing calculator. But whatever your method, they're going to let you use some rounded off decimals. If you had to use these exact ones like you see here in the quadratic, then you would have to just simplify that.